Hello students, this is AMOL INGOLE, and in this video I am going to explain trellis diagram. Trellis diagram is one more way of representing convolution encoder. Trellis diagram represent linear time sequencing of events similar to code tree. Horizontal axis in trellis diagram represent discrete time steps, whereas vertical axis in trellis diagram represent all possible state of the encoder. I hope you know what are possible state of the encoder and how you can identify those possible state from the given statement, numerical statement. Trellis diagram can be drawn from code tree, or you can also use the encoder's response table. Trellis diagram is more compact. It is used to trace the output of encoder. Advantage of trellis diagram: it avoids the redundancies of code tree. So we'll see this when we complete this video, how it avoids the redundancies which we could not avoid in code tree. This is how your trellis diagram will look. These are the horizontal discrete time steps. You can see this first time step from here to here, second time step from here to here, third and fourth, fifth. So this particular trellis diagram is drawn with 5 time steps. So you can use this to encode or decode input of 5 bits. Vertical lines are used to represent your possible state of the encoder. So this is one example showing 4 possible state. If you compare this with the tree diagram, this is how a tree diagram looks, and this is your trellis diagram. So to understand how this trellis diagram is constructed, we're going to consider one numerical. This is the statement of the numerical where two generator sequences are given, G1 and G2, and you have to construct a trellis diagram and encode the input stream. There are 5 bits in the input bit stream, U10101. The first thing that you have to do is construct a response table, because to construct a trellis diagram, the first thing that you will need is to construct a response table. So I'm not going to explain how to construct a response table for a convolution encoder given. This is the response table for the numerical given, and you will see that there are 4 possible state. Why? Because there will be 2 memory units and there will be 2 raised to power 2. That is 4 possible state. Let us start constructing a trellis diagram from the response table. This is the first thing you should do. Okay. So the first thing in constructing a trellis diagram is show all possible state. So as we have identified that there will be 4 possible states for this encoder. So I'm showing them with A, B, C, D. 0, 0, 0, 1, 1, 0 and 1, 1. These are the 4 possible state, and these are our time steps. As we have 5-bit input bit stream for encoding, so I'll be constructing a trellis diagram with 5 time steps. So this is the first time step from here to here, second time step, third, fourth and fifth time steps. So it depends how many input bits are given to you to construct the trellis diagram. So as we have 5 bits, I'm showing 1, 2, 3, 4 and 5 time steps. So these are our time steps horizontally, and vertically these are our possible states. So you may be at any time step. So for example, if I'm considering the third time step here, first, second and third time step. This will be your 0 0 state, this will be your 0 1 state, this will be your 1 0 and 1 1 state. So you may be at any time step, you can go vertically downward direction, and you will see that these are our states for that particular time step. So let's start with the 0 0 initial state. You are supposed to start with a 0 0 initial state. So here this is our 0 0 initial state from where you have to start. So when the encoder is in 0 0 state and 0 input is given, this will take you to the next state, which is again 0 0. So when 0 0 is the initial state, 0 input given, there is no change in the next state, right? You will remain in the next state. So this thing can be shown with a line like this. You were in a 0 0 state, input 0 was given, so you will go to the next state, which is again 0 0 state, right? So because this complete line is for 0 0 state, so you have to show a direct line going from here to here, and this 0 0 is the output for that particular input. 0 0 is the output, so we're going to show the output on that line, right? Now whenever you are in 0 0 state and again 0 input is given, you will again be in the same state. So this thing can be shown, right? You are at this time step, again 0 input given, so this will take you to the same 0 0 state, right? So this thing can be repeated for all the remaining time steps, because every time you will be at 0 0 state, 0 input given, you will go to next 0 0 state, and the same thing can be shown like this, right? So the first row of the response table is completed. Now let's go to the second row of the response table, where again you are at 0 0 initial state and one input is given. The input bit is now 1. So from here you have to start, right? This one was the starting point of our trellis. So with input 1, it will take you to the next state, which is 1 0. You are in 0 0 state, input bit is 1, it will take you to 1 0 state. Where is 1 0 state? Here, the third line is a 1 0 state. So from this 0 0 state, you have to draw a dotted line. Why dotted line? Because we are going to consider dotted line for 1 bit input, darker line for 0 bit input. So let's show this with a dotted line from 0 0 to 1 0 state, and this 1 1 is the corresponding output. The 1 1 is corresponding output, right? So this thing can be shown for all the 0 0 state with input 1. So again, at this time state you are in 0 0 state. So from here, when input 1 is given, it will take you to 1 0 state. So this is how you can repeat the process from 0 0 to 1 0, from 0 0 to 1 0, from 0 0 to 1 0, and show that with a dotted line and show the output beats for that particular state change. This is how you can show it. For all time step, you should show this. Okay, so we have completed first two rows of our response table. Okay, now look at this. You should not start with 0 1 step. Why? Because for this particular encoder, there will not be any case where you are starting from 0 1 state. Why? Because you have to start with 0 0, and when you start with 0 0, the possible input bits will be either 0 or 1. So if it is 0, it will take you to same state. If it is 1 bit as an input, then it will take you to 1 0. So this is from where you should start. Okay, so I'm starting now this with 1 0 state, 1 0 state. From here you should start now. So you are in 1 0 state and again giving input 0. So from 1 0 state, when 0 input given, it will take you to 0 1 state. So from 1 0 to 0 1, you have to show a darker line. So from here I am going to show it. Look at this. From 1 0 state to 0 1 state. This is our 0 1 state. And 0 input is given, so I'm showing this with a darker line with output 0 1. You can see this output 0 1. The same thing can be shown for all the remaining time steps from this time step onward. Okay? You should not show it from here. I'm going to show it from this time step onward. So I'm going to show it here, here, as well as here, like this. Remaining time steps means from this time step onwards, whenever you will be in 1 0 state, it will take you to 0 1 state when input 0 is given. Darker line indicates 0 input, and this 0 1 bits show the output, corresponding output when the state changes. Okay, now again you have to start with the same state, that is 1 0, but this time with input bit 1. So when the input bit is 1, it will take you to 1 1 state, which is here. These are the 1 1 state dots. So from here you're supposed to show it. You should not show it from here. From here you should show like this, and with a dotted line, because input bit is 1. So from 1 0 state, if input 1 is given, it will take you to 1 0 state. That's how you can connect this. You should not show from here to here, because the time state will change. The time step will change when input bit is given 0 or 1. So the next time state, you should go to the next time step, not in the same vertically downwards time step. Okay? So this thing can be repeated for all the next time step from 1 0 to 1 1, from 1 0 to 1 1, like this. You can repeat for all the remaining time steps like this. Okay. Now we have completed 0 0 state. We have completed 1 0 state. Now 0 1 and 1 1 is left. Now let's start with 0 1 state. If you start with 0 1 state, you should not start from here. You should start from this time step onward, because there will not be any situation for any input bit stream where you will need to start from here. Right? So you have to start with this time state onwards. So let us see this 0 1 state. When input 0 is given, it will take you to 0 0 state. So from 0 1 state to 0 0 state. So from here it will go to 0 0 state. These dots are for 0 0. So this is the state change when input bit is given as 0. So darker line is used, and it is also showing output 1 1. You can see this output 1 1. The same thing can be shown for input bit 1. When you are in 0 1 state, input 1 is given, it will take you to 1 0 state. Right? 1 0 state. Before this, you can first show this 0 1 to 0 0 for all remaining time steps. So I forgot to do that. You can show it like this. So for all the remaining time steps, you can show it like this. Now we will consider input bit stream 1, input 1 with the 0 1 initial state, and it will take you to 1 0. So from here it will take you to 1 0 state, like this. This is how you can show it. From 0 1 state, when one input is given, it will take you to 1 0 state. So here is the 1 0 state. 1 0 state. So you can show it with a dotted line, because one bit input is given, and these 0 zeros represent the output for that. Right? 0 0 represent the output for that. Okay, so we have completed this 0 1 state as well. Now the last state which is left is 1 1. So again, you should not start with this time step. From where you should start? Here, because this is where the last time the state change happened. So from this time step you should start. So we are in 1 1 state now. 0 input is given, it will take you to 0 1 state. So from 1 1 to 0 1, you can show it like this. From 1 1 state, it will take you to 0 1 state when 0 input is given, right? And this 1 0 is the corresponding output, right? And I am showing this for all remaining time steps from this time step onwards. Okay, now the last row, that is you are in 1 1 state and one input is given, it will take you to the same state, right? So there won't be any state change when you are in 1 1, input 1 is given, it will take you to same state, right? So this can be shown with a straight line, straight dotted line like this. From 1 1 you will be in the same, there won't be any state change. So no state change will be shown with horizontal line like this. Dotted line is used because input bit is ones. This 0 1 represent the corresponding output. So this is how you can complete the trellis diagram using response table. Now let us show the encoding of the input string. I'm going to consider the same trellis which we have constructed just now. This one is the input bit string given. Now you have to consider the actual input bits one at a time. I'm starting with 0 input bit. So here is our first input bit 1. You have to again start with the 0 0 state. The first input bit is 1 here. So when the input bit is 1, we have already constructed the trellis. Which path you should follow? Input bit is 1, so you should follow the dotted line. You should follow the dotted line. So this is the trace on the trellis. This is how the trace on the trellis is shown. So you have to follow that dotted line and you have to pick up this output. These are the output bits you should pick up and write it here. So 1 1 is the output for one input bit. Okay, and that will take you to this state, 1 0 state. Okay, the state should not be written anywhere. You just need to follow the lines and the output bit should be encoded. Output bit should be taken. Okay, so you will be at this state. Here, the next input bit will be 0. Next input bit will be 0. So when you take 0 input bit, you have to follow the darker line. So from this time state, you have to follow darker line. Here is the darker line, right? And that will take you to this state. What you should pick up from here? The 0 1. 0 1 is our output bits when the input bit is 0. Right? So this 0 1 should be taken from here. Now you have to start with this time step. Next input bit is 1. Next input bit is 1. So when the input bit is 1, you have to follow dotted line from this step. From this step, follow the dotted line. Following the dotted line, it will give you output 0 0. So this 0 0 output should be written for the input bit 1. Let's consider the next input bit, which is 0 now. Input bit is 0. So from this, you have to follow darker line. Why? Because input bit is 0. So from this node, you can follow the darker line leaving this node, and that will give you output bits 0 1. So this 0 1 output bits is written here. The last input bit is 1 now. 1, right? And you have to start from where you ended, right? So this is where we ended from the previous bit. So last bit is 1, you have to follow dotted line. So this is the dotted line and the output bits are 0, 0. This is how you can encode the given input stream using Trellis diagram. And you should also show that trace on the trellis. This is how you can use a zigzag line over the trace to show the trace on the trellis. That will show you how these input bits are encoded and you get the output like this. Thank you very much.